Okay, number 13. Given the reaction, how many moles of H2O are needed to exactly react with 2 moles of calcium? Okay. Always check and make sure that the equation is balanced first, and it looks like it is because the number of calciums are equal on both sides, number of hydrogens are equal, and the number of oxygens are equal just by looking at it. Okay. So remember, our first step is to circle the 2 chemicals in the chemical equation that we need to work with. So it's how many moles of H2O are needed exactly to react with 2 moles of calcium. Okay? So remember your steps. First thing to do is write down your given. So I was given 2 moles of calcium. Okay? Next step, set up your ratio. Copy your unit from the given to the bottom. And what you're looking for on top. So we're looking for moles of H2O. Next step is coefficients. What's the coefficient of calcium? 1, because there's nothing before it. What's the coefficient of H2O or water? It's 2. I'm getting that from the chemical equation. Okay, so in the calculator or using your mental math, 2 times 2 over 1 is 4 moles. Number 14, the volume of a sample of gas is 1 liter. As the temperature decreases, pressure remains constant. The volume of the sample will A, increase, B, decrease, C, remain the same, or D, not enough information is provided. We have to remember that we have to remember our gas law relationships. So this one, it's saying pressure remains constant. So we have a volume of a sample being 1 liter, and the temperature is decreasing. Okay? And I need you to think of like a scenario that makes sense to you. Think about a balloon, okay? And as the temperature of the balloon decreases, what would you expect the volume of the balloon to do? Well, it only makes sense that as things get colder, or as a gas gets colder, its volume also decreases, okay? And we saw that in the lab where I put a balloon on top of a flask and I heated up the water in the flask and it made the balloon expand. And then I took the flask and I submerged it in cold water and the balloon got sucked into the flask. That was because the volume of the gas decreased. Okay, number 15, what is the mass of 3.5 moles of nitrogen gas? So what you have to do here is it gives you N2. In order to find mass, this is a triangle question. Grams on top, right? That's mass. Mole. Molar mass. Okay? So if I'm given moles, but I need grams, you're always going to be able to calculate molar mass. So you know the molar mass, you know how to do it. You guys are really good at it. N, there's 2 of them. Look at your periodic table, 14.007. Okay? So in my calculator, 2 times 14.007. That equals the molar mass of nitrogen gas is 28.014. Okay, that's the molar mass. Okay, so then we go back, moles times molar mass if I'm trying to find my grams. Okay, so moles, 3.5 times, that's mole, times 28.014. So when I do that in my calculator, I get 98 grams. Okay? Number 16, I really like this question. It says, which formula is correctly paired with its name? And there's a ton of different ways to figure this out. So let's go one by one to see which one is correct. The best way to do this is to really look at the oxidation numbers to make sure that it's going, you're doing it correctly, and then to remember your rules. So it says A, FeO is iron 3 oxide. Well, if we look at iron 3 oxide and its oxidation numbers, Fe, if it says iron 3, that means the oxidation number is a 3, right? And then the oxidation number of oxygen is -2. So if it was iron 3 oxide, truly, you would crisscross the 3 and the 2. So it can't be A because there's no subscripts at the bottom of that chemical formula. B is copper 2 chloride. We can do the same thing where we write out the oxidation numbers. Cu is copper, and then 2, so that's a +2 on the copper. And then chlorine is a -1, so when you crisscross drop, that is CuCl2. Okay, so let's see if it might be that one. C, K2O, potassium dioxide. No, dioxide is only for covalent compounds, the prefixes. We don't use the prefix di, okay? It's potassium. This is potassium oxide, okay? So because that prefix di is there, it's wrong. Let's look at magnesium chlorine. Almost correct. Remember, the rule for ionic compounds is that we use the prefix or the suffix "ide." So this should be magnesium chloride. Okay. So D is tricky because if you do check the oxidation numbers, it's magnesium +2, right? And then chlorine -1. So the chemical formula is right, but the name is wrong. Okay. So it looks like B is the correct answer. Okay. 17, as the elements in period 3 of the periodic table are considered from left to right, the atomic radius tends to, and we have to pick increase, decrease, remain the same, or first increases, then decreases. Okay, I know this one might get you a little confused, but you have to remember that if we look at period 3, that's sodium in group 1, and it goes all the way to chlorine. Okay, we can consider argon as well, but let's just work with chlorine. Sodium, since it's in group 1, has 1 valence electron. Chlorine is in group 17. It has 7 valence electrons. Okay? And you have to remember, in order to understand atomic radius, that sodium, if it has 1 valence electrons, it sends it out, so the radius is larger. Whereas chlorine says, hey, we only need 1 more to be stable. Y'all stay close so that we can add 1 to become stable. So atomic radius tends to decrease as you go left to right, okay? Because it's increasing that way from chlorine to sodium, which means it decreases going back. Okay, so just be really careful with that one. Which substance has vibrating particles in fixed positions? Remember, we have solids, liquids, and gases. Gas particles move all over the place, so they don't have a fixed position. So it's not O2, represented by the G. Liquids are able to move So they don't have fixed positions because the word fixed means still.